In this slide, we have all the rovers that are on Mars. Some of them not working anymore. Like, for example, Sojourner was the first one back in 1997. And then Spirit and Opportunity were these twin rovers. Opportunity lasted for a long, long time. Spirit landed in a different part of Mars. It had a lot of problems. It made discoveries as well as Opportunity did, but Opportunity seemed to have been the more successful one. All right, and then the newer rovers are called Curiosity, and the latest one is called Perseverance. Perseverance is the one that brought the helicopter with it. All right, so these are just models, of course, of the rovers. They're not the actual ones. All right, so Curiosity, it's about an SUV, as a small SUV, right? It's about the size of a small SUV. Reached Mars in 2012. It went down into Gale crater. It actually went to other craters as well. I posted some of the videos on the Curiosity rover, or at least one video on the Curiosity rover. And when they go from crater to crater, it takes a long time. Like it takes years, because these things are incredibly slow, and they're designed that way, right? They're designed to be very slow because the terrain on Mars can be very hazardous. For example, the Spirit rover got stuck in some sand dunes for a long time, actually, and I think they were finally able to get it unstuck. But then one of its wheels jammed, and so it was like dragging one of the wheels for a long, long time. But even that gave us some insight. We actually found like salty material underneath where the wheel had dragged. So that was kind of an interesting. It wasn't something that was planned, but they made that discovery. So on Mars, you see these layers of rock that are up to 4 billion years old. That's actually very unusual. You wouldn't find that on the Earth, right? Because remember, the Earth is an active world, and so its surface is being rewritten all the time, right? Through the convection, the heat that wells up in the center of the planet, and then travels outward and through the convection, and then you have volcanic activity, you have plate tectonics. That's not going on Mars. In fact, we actually landed a sensor. I think it was called InSight. The InSight sensor landed on Mars. It wasn't a rover or anything, but it was a seismic detector, and it looked for Mars quakes. All right. Anyhow, all right. This is talking about Curiosity rover. It's there's this mountain there that's near Gale crater, relatively near Gale crater. Actually, not too close, but it's called Mount Sharp, and they've been climbing it and trying to learn more and more about the past. There's ample evidence from these rovers that Mars once had had water on the surface, but that water is gone now, and the question is, what happened to it? Right. That's all right. So this is there's where the Curiosity rover up right here. Right here is where it landed. There it was in early 2022. All right. so I think this is Mount Sharp in the background. Um, yeah, so. All right, anyhow, that is some of the stuff that the rovers are doing. In the videos that I posted go much more into detail about the kind of things that they discovered. I mean, it's actually interesting that a lot of this stuff now is not really in the realm of astronomy. It's more like geology. As a matter of fact, is like some of the rocks, for example, that were found and could have only formed, or some of the minerals, I should say, could only have formed in water, for example, and that's another reason that we think that Mars once had possibly even liquid. I don't know if they were oceans. Especially in the northern hemisphere of Mars, which is lower in altitude than the southern hemisphere, and so that looked like there were what, well, at least seas, really large seas, possibly oceans. All right, so let's talk about Mars's atmosphere for a little bit. There is wind, even though it's a very thin atmosphere with only 1% the density of Earth's atmosphere. So, for example, right, if you take the density of the Earth's atmosphere at sea level, right, at sea level, we're basically as long as you're not on top of a mountain, you're at 1 atmosphere of pressure on the Earth, right? So if on the Earth, if you were to go up 100,000 feet into the air. Okay, so 100,000 feet. Now keep in mind, commercial jet airplanes travel at about 33,000 feet. So there's very few airplanes that can go all the way up to 100,000 feet. But if you were up that high, that would be the density. That would be about the density of Mars's atmosphere. Nobody can breathe up there. Besides the fact that, of course, Mars doesn't have a lot of oxygen. Most of its atmosphere is made of carbon dioxide, and there's a little bit of nitrogen. There is some oxygen and water vapor that's in the atmosphere, but not much. Not much at all, as a matter of fact. Like way less than 1%. Most of the water is trapped is frozen in the ice caps. It's a mixture of frozen water and frozen carbon dioxide. Dry ice, right? That's stuff that if you went to the supermarket and you wanted some dry ice, that's what it is. It's frozen carbon dioxide. All right, so that's the atmosphere, or a little bit about the atmosphere. So because the atmosphere is so thin, the temperatures vary greatly on Mars. Okay, so let's say if remember that Mars is tilted currently by about 25 degrees. So let's say it's summertime in the northern hemisphere on Mars. Okay, so summertime in the northern hemisphere, the sun's rays are more directly hitting the northern hemisphere, and so let's say it's summer. That is you might barely be able to get up to about 50 degrees Fahrenheit. All right, so 50 degrees Fahrenheit. Humans can certainly live in 50 degrees Fahrenheit. That's not too bad. You probably want a jacket, a light jacket or something like that, a sweater on. But anyhow, at nighttime now. So at nighttime, it goes way down. Okay, so the nighttime temperature gets down to negative 67 degrees Fahrenheit. Okay, that's 218 Kelvin. So that's unbelievable. That is really, really low. Um, and so just as a comparison, like let's say you're in Alaska or something like that, uh, in some far northern location on the Earth, maybe it'll get to negative 20 degrees Fahrenheit, and that's a rare thing. That hardly ever happens. All right, so I mean, maybe a little bit more, negative 25 or something like that. But never, ever on Earth do you see temperatures at negative 67, right? So, but that's a every night on Mars. And remember, Mars rotates around, and it takes about 25 hours for Mars to rotate around. Not quite, but it's right around 25 hours for it to spin on its own axis. So it's nighttime. Um, one Martian day, you're experiencing this incredible temperature. And by the way, we had when we built the rovers, right? That we started with this video with. Those rovers had to survive this temperature, right? Well, really, the temperature difference between sometimes being at plus 50 degrees Fahrenheit and down all the way to negative 68, 67 degrees. So as I mentioned before, most of the water is locked up. So it never gets to positive 50 degrees Fahrenheit exactly at the poles. The same reason that it doesn't get that temperature at our poles, right? The poles, they never really face the sun. I mean, they'll get some sunlight, of course, during the summertime, and during the summertime, of course, if it was summer in the southern hemisphere, the south pole of Mars gets smaller, noticeably smaller, and the same thing with the North Pole. When the northern hemisphere is in summertime, it noticeably gets smaller. And what that is that the ice is now it doesn't melt. Okay, so that's that's something I have to explain. So it goes directly from a solid into a gas. When it does that, that's called sublimation. All right, so that's really what's going on with the poles. That's why they get smaller. And now, what happens to it when it becomes a gas? Well, it adds gas molecules to the atmosphere, which is mostly carbon dioxide, right? Carbon dioxide, a little bit of nitrogen, and just a touch of water. This is just showing us that Mars does have an atmosphere. It does have weather. This is a little dust devil that was captured. This picture was captured probably by the Mars Reconnaissance Orbiter, if I had to guess. Oh yeah, it says it right there. Look at that. So the Mars Reconnaissance Orbiter is a spacecraft that's constantly orbiting Mars and taking pictures of everything it can. It can take really detailed pictures of the surface of Mars, as you're going to see. Actually, there's a slide coming up that shows some pretty amazing detail. All right, so anyhow, the clouds are made of course, the clouds on Venus are made of not Venus, sorry, wrong planet. On Mars are made of dry ice and water ice crystals, and they blow around. Let me mention this. I think it was in 2018. There was a dust storm, a major dust storm on Mars, and it basically kicked up so much dust around the planet that from Earth, when you looked at Mars for a little bit of time there, a couple of weeks to I think it was maybe even a month long, you couldn't actually make out the surface of Mars. The dust was so heavy. But then